Okay, the sine rule. So, with the sine rule, it's basically a way of finding angles or lengths in non-right angle triangles. So most of the trig that we've dealt with has been dealing with trigonometry of right angles. Now, these rules that we're going to be looking at in the next few lessons are related to triangles that are not right angles. It's as simple as that. So we're going to start off by defining a triangle ABC. Here's a triangle. I'm going to call it A, B, and C. And those are all capitals. What we're going to do is we're going to label the edges of this triangle with the lowercase abbreviations, A, B, and C. Now the sine rule says that in any triangle ABC, labeled like the one on the left, the relationship between the side and the sine of its angle are equal. And we've looked at this rule in year 10 as well, but effectively, this rule is saying that this length here is related to that corner. Okay, in a way such that this length here is related to this corner, such that this length here is related to this corner. And you can kind of see it too. If I was to increase the size of C, make the angle in here bigger, what would happen to C? Okay, well, B would get pushed out to here, and that means that the length of C would actually also increase to make up the distance as well. So the distance between, or the distance or the length of the triangles are related in a way such that if I was to increase the sizes of a length or an angle, then their side length would increase, or the angle or side length would increase as well, depending on that. And now what this is saying is the ratio between the two are equal no matter which ones you're looking at, and that's meant to be a C, not a B. Okay, so if I was to look at the relationship between this side and this corner, it's the same as the relationship between this one and this corner, okay? So that's all it means. And we can use that rule, or that fact, to calculate other angles or side lengths in our non-right angle triangles. Okay? And so we're going to do some examples showing exactly that. So let's have a look. In triangle ABC, given that A is equal to 45 degrees, B is equal to 30 degrees, and BC is equal to 5 centimeters, calculate the size of C, B, and C. So C, capital C being the angle, B and C being the small sides. So first up, we're going to actually draw the picture of this. So triangle A, B, C, where A is 45 degrees, so that means that corner in there. B is 30 degrees, so talking about that corner in there. C is unknown, so I'm going to call it theta for now. Actually, no, I'm not even going to call it anything. I'm just going to leave it as it is. And BC, so that's the distance between B and C, is 5 centimeters. Okay, so what we need to do is calculate this one here, and this one in here. So we'll start off with C, because it's actually a lot easier than it says, or it looks. Now, we're actually going to be applying trig to our angles later on. What we're going to do now is we're just going to use the fact that the angle sum of a triangle adds up to 180 degrees. So 180 degrees minus the other two sides will give us the side length of, or the angle length of that angle, the size of that angle. And by just doing that simple subtraction, we get that C is equal to 105 degrees. Okay, it's that C. It's that simple. 105 degrees in there. Now, we're going to use some facts about this triangle to work out what these two side lengths are, so A and C and AB, so AC and AB. Now, it's imperative that you use the ones that are opposite, so it's always the side and the opposite corner are the parts that correspond. So what we're going to do when we write out our sine relationship to solve this problem, it effectively comes down to this. A over sine A is equal to B over sine B. We only are concerned about two of the parts, okay? Because even though the relationship is the same between all three, okay, we only need two parts, or we only need to know what one of the relationships is, plus something else about the other. Okay, so this basically boils down to a formula. And the formula is that the unknown side, okay, over the sine of opposite angle is equal to a known sine divided by its sine of opposite angle. Okay. So effectively, this is what we're going to be using to try and solve these problems. So we need to find what the unknown side is first. Okay, so let's start off with b. So this unknown side, I'm going to give it a little b. So unknown side is b, divided by sine of the opposite angle. So the opposite of this b here is this 30 degrees. So it's the sine of 30 degrees, or sine 30 degrees. And that's equal to the known side. So the only known side we know is this 5 centimeters here. So we're going to use that, 5 centimeters, over the sine of its opposite angle. So sine of, and in this case it's 45 degrees. Okay, now we just need to rearrange this for b. So what I'm going to do is multiply both sides by sine 30 times by sine 30. And so we get b is equal to 5 lots of sine 45 degrees times sine 30. Now you can put sine 30 first and then multiply it by 5 over sine 45, doesn't really matter. But we put that into our calculator and we get an answer of 3.54 centimeters to 2 dp. Okay, so that was for B. Now we're going to do C. C is going to be this one down here. Okay, so we do have its angle now, which is 105 degrees. So we're going to rewrite our equation as C over sine of 105 degrees. And that's equal to, and it's going to be the same relationship, or the same ratio as we used before, the A one, because we know that it's exactly 5 centimeters long, because it was given to us in our question. So always use the information that's been given to you. Don't use this one here. Even though it should technically give you the same answer, but because we've rounded this to 2 decimal places, it's going to be a little bit off. So use the one that we already know. So 5 over sine. So what I'm going to do is I'm going to multiply both sides by sine 105 degrees times by sine 105 degrees. And so we're going to get C is equal to 5 over sine of 45 degrees times sine of 105 degrees. Okay. Again, putting that into your calculator, you get an answer of 6.83 centimeters. Okay. So that's pretty much how you do it. That was just finding the side lengths. Later on, we're going to be having a look at how to find the angles as well, but it's pretty much the same thing, just with a little bit of a difference. And we're going to have looking at the ambiguous case in a moment, but first, after this, or in the next video, we'll be looking at the area, or how to find the area of a triangle, or right angle triangle, non-right angle triangle.